Welcome to Cloud Lanes and the Cloud Lanes Backup Accelerator. This series of videos will show you first how to download the correct image for your particular hypervisor and to deploy that image properly. Step 2 will be to configure your cloud storage account or accounts in your cloud storage provider. Step 3 will be to create the Backup Accelerator Vault, where we store all the data that you back up, first initially on premises and then moving it to the cloud. The fourth step is connecting the Windows server on which you are running your backup software to the Cloud Lanes Backup Accelerator with the iSCSI initiator. The final video will be a walkthrough for configuring with best practices your backup software and running through all the functionality to backup and restore using the Cloud Lanes Backup Accelerator. This is the fifth and final video in the series, which will show you how to configure and use your backup software with the Cloud Lanes Backup Accelerator. So at this point, we have downloaded our Backup Accelerator image. We have deployed it to our hypervisor. We have configured it by adding our cloud accounts and then inputting those into the software deployment. We then connected to the Backup Accelerator with a Windows server, which will be running our backup software. And now finally, we will configure the backup software itself to communicate with the library and walk through usage. Here we will be demoing with veeam. Have a veeam server here. I'm going to run veeam backup and replication. Again, you can see I'm running version 9.5 here. The interface for 9.0 is identical. While I'm waiting on that to load, let's check the iSCSI initiator. We can see here that we are connected. You can see the cloud lanes there and all those devices. And once again, let's check Device Manager, show that we have our medium changer and our tape drives. So now we have veeam. Now I won't be going into the details of full veeam configuration, discussions of the backup repository and so forth, but what I have here is a very simple environment with a standalone veeam backup and replication server that is currently backing up two of my demo domain controllers here. Note, one of them is coming from VMware, one is coming from Hyper-V, so pretty typical implementation. What we need to do now is go to the tape infrastructure node. If you don't see this node, normally it's hidden. You can simply click over here and you'll see it in the list. Once we click on tape infrastructure, we want to add a tape server. Now in the world of veeam, this could be any Windows server in your environment. Again, in a smaller environment or a demo environment like this, there's no reason you can't use a single server for this role. We won't configure any special traffic parameters on this. Review, and now it's installing. Note that the very last step, it's looking for the tape libraries, getting information on them, that is, what type of library are you, how many drives do you have, and so forth. The tape server role has now been deployed to this machine, and note here this checkbox, start inventory when I click finish. We will allow that to happen. Now again, when we created this vault, we only created it with 50 tape cartridges to limit the amount of time it will take on an inventory. If we actually go up to our tape infrastructure, down to libraries, expand this library, Storage Tech L700, that is what we're emulating, we can see the 8 individual tape drives, and here is the media. So the 50 tapes that we saw in the vault when we created it, and you can see here it is walking through those tapes one by one to inventory them, look at them, see if that has any marker on it. It starts by reading the barcodes, and if it finds that the tape is unused, it will mark it free and put it in the default media pool of free. And we'll talk about media pools in just a moment. Let's let this inventory complete. All the tapes have now been inventoried. You can see the job is no longer running, and the drives are empty, except for one last tape. Guess it didn't finish completely there. Let's go up to media pools, talk about this a little bit. So you can see here, if you haven't worked with tape in veeam before, what it does is keep tapes for different purposes that you can define in so-called media pools. The default pool, free, as you can see, is where tapes end up that are new or have been freshly formatted. So again, just a default pool. The best way we found typically to structure media pools is around retention time. So let's say that you have multiple retention requirements. Some of your data you need to retain for 1 year, some for 3 years, and maybe some for 7 years. Typically what I will do then is create a media pool for each of those. Create one for 1 year retention. Choose the tape library. We have just this one. And what we will do is pre-allocate some tapes. Let's just do 5 tapes for this particular media pool. But note, there's also this checkbox here. If you aren't sure how many tapes you're really going to need to accommodate that based on your data growth, you could plan the best that you can, but you may end up not putting enough tapes in here. Again, a default installation of the backup accelerator has 2,500 tapes, so it's unlikely that you'll run out. The point is simply that if you keep this checkbox checked, if this media pool runs out, if these 5 tapes end up being used and are unavailable for further backups, it will automatically add tapes to the pool from whatever's left over in free. So you're covered. You don't have to think too hard about how many tapes to put in here. Media set name, I will keep that. Data retention policy. So here's the key. We're going to set the retention for 12 months. Okay. Next, we're going to create an offline media vault. So again, what happens here is that once we write a backup to tape, what we want to do is move it to the cloud. The mechanism we use for that is a tape export. In the real world, that would mean physically the robot moving the tape in question to a media access port on the library. The door would pop open, you'd walk over, grab the tape, put it in a lockbox, and ship it off-site with your off-site provider. Here, the CloudLane's backup accelerator will listen for that that export command, and when it receives it, it will automatically move that data up to the cloud. But once a tape in either of those scenarios, physical or virtual, leaves the tape library, the software has no idea where it is. Veeam offers functionality to create these so-called logical offline media vaults so that it can track where they're going, so you know where they are. They're not just missing from the device. So what we'll do is add a media vault, call it 1 year vault, and I'll protect all tapes moved there automatically so they can't be overwritten. There we go. Now we're back to the media pool screen. Next, if I have multiple data sources in a given backup job, you can enable parallel processing. I'll allow this to use up to 2 drives simultaneously, parallel processing. Here is where you will enable encryption. Again, we highly recommend that you do this. You do have encryption in Azure storage accounts if you are using Azure storage, but it's always best to enable encryption when possible in the backup software. Here I'm going to leave that off just for demonstration purposes. Finish. Now I'm going to create 2 more pools for the 3 and 7 year retention periods. Now in this case, because we're protecting it for 3 years, we'll protect for 36 months. Same thing, parallel processing, done, and 1 for the 7 year. $84 months. And move to, you can see the other vaults there. Let's add a 3rd vault and protect. And done. If we look in vaults, now we can see we have these vaults to track tapes that have been sent off-site. So now we have our tapes in place. They've been inventoried. They're ready to be used. Drives are ready to go. We have, you can see here, if we look at media, some of the tapes have been allocated specifically to those media pools for the different retention times. Next, we'll create backup jobs. Once you have a tape library or virtual library configured, like the Backup Accelerator, you will see now a new button called Tape Job. And there are two options here. Tape backup of files. This can be very, very useful. Direct file to tape backup without use of the veeam repository. If you have some very, very large file shares, for example, that are served up by multiple file server VMs, and you do not want to back up all those file shares as part of your veeam image of those file server VMs, what you could do potentially is do a direct file to tape backup where veeam will connect directly to the file shares and back them up straight to tape. Again, that does not take up any space at all in your veeam disk repository for on-site retention. For this case, we will back up a backup. Just accept the defaults, and you can back up an entire repository or you can back up specific jobs. So let me back up my DC2 job that was coming from VMware. And for this one, I'm going to keep this in 7-year retention. Straight to tape, sorry, 1-year retention. Straight to tape, 1 year, and I'm not going to do any incrementals. Again, at this point, what we're doing is doing all full backups to the tape and then off-siting those. You can do incrementals to tape, but if you do that, there's a slightly better way to do it that I'll show you shortly. So for the moment, we're just configuring the full backups. This screen is very important. Number one, eject media upon completion. You do want to check this. What that does is that when one of these virtual tapes is finished being written to, it will eject the tape from the virtual drive and return it to its slot. Okay, that's important because if the tape is left in a drive, that drive will be unusable for other jobs until that tape is ejected or until it's needed again. So a best practice is to check that box to eject media. And again, that is not export. Export is the next checkbox. Export is when we instruct the tape library from the software to off-site the tape. Again, in the physical world, that means physically moving it out of the machine so that you can take it and bring it off-site. In our world, that means moving the data to the cloud. Now, under normal circumstances, when you have your tape jobs all designed, running automatically, this is what you want to do, because once your full backup job is done running, you'd want to send it up to the cloud as quickly as possible, and we would check this. Just for demonstration purposes, I'm going to leave it unchecked. Run the job automatically. Again, production implementation, you'll want to schedule this when you would normally do your full backups, so it could be weekly fulls. If your data set is small enough and your internet connection large enough, you could have simply tape jobs being run every day directly after the disk backup jobs. But either way, you'll want the tape jobs to run after your last disk backup, your D2D backup occurs, so we can get the latest data. Here, again, for the demo, I'm not going to run it automatically. So now we have that backup job. So I have 2 D2D backup jobs backing up VM images of these 2 domain controllers that I have here. And now I've created a job to send to 1-year retention the DC2 backup. So let's start that backup. While this backup job is running, you can see it is backing up to tape. It's in process. Let's go over to our tape infrastructure, take a look, and you can see here we have 1 media right now, 1 tape that is located in drive 2 with an expiration date automatically set a year out. It is in the 1-year retention pool when it's done, and it's part of this media set for this particular backup job that's going on. And that backup is now complete. Let's take a look one more time at our media pools here. We can see that the tape that was used is back in its slot. It's no longer in the drives because the job is done, but it's still on site. It's not in our offline vault yet. So the next step would be to take a look at the Cloud Lanes Backup Accelerator interface. So here is our web interface where we can see at a glance various system statistics, system throughput. You can see here a significant amount of ingress. That would have been during that backup job. And if we go to our tape library, take a look here, you can see tape number 1, the one that was used in veeam, the same barcode, now 8 gigs used. The reason these other tapes that are brand new have a little bit of data showing on them is that's just the Cloud Lanes metadata, so that we can recognize those tapes, plus a little bit from veeam itself. Remember when it marked those tapes as being available for use. So now we have that backed up locally. But again, we did not actually export that data. So it's still sitting locally here. It has not yet been sent up to the cloud. In a situation like this, it is possible to manually export these. There is a button here, Export Cartridge. The problem is that the veeam software currently thinks that the tape is still in the library, and it may get confused if we do it there. Which is why when we are exporting, we should always do it through the backup software, not through this interface. So let's go back through veeam. Before I do that, let me do another backup job. I had mentioned that option to do file to tape. Let's do a small file to tape job so you can see how that works. Again, one of the great advantages here is that it doesn't take up space in your veeam repository. So again, a great use case is you have large file shares that may be presented by one or more front-end file servers, DFS servers for example, and you don't want to back up all that data with each of those VMs. What you can do is do it directly. So here I'm going to connect to a share that I know exists, and it will use the credentials that you provided already for veeam. If you do not have suitable credentials, it will prompt you to add them if it has trouble connecting. So this is just a very tiny share, a couple megabytes worth of data in it. Going to back everything up. Media pool, full backups, same thing. Let's give it just 1 year retention. Although, again, I could pick any, let's go with 3 year retention so we can see the other one in use as well. I won't set it to run automatically this time. And again, for incrementals, we could specify those, but we'll be talking about that again in just a few moments. So I'm going to leave that alone, not run incremental backups. Do want to use Microsoft Volume Shadow Copy. And once again, media automation, we do want to eject upon completion. Now, one other option, I'll show you this time, is that export. Again, we can issue a manual export command, such as with that last job. That was just backed up locally. We didn't instruct the backup accelerator to send that data to the cloud. In this case, we'll tell it to do so immediately as soon as the job is done. And this time, I'm going to run it right away. Let's watch what happens. You can see that it is now started. There we go. So the job is now finished. You can see some things happen very quickly. Ejecting tapes used by backup. It was using this particular tape, ejected it from the drive. Well, what does that mean? Let's go back to tape infrastructure. First, let's take a look at our pool. Okay, so we had our 1 year retention, location slot 1. Remember that first backup job we ran it locally. We did not export the tape, so it's still sitting locally in our landing zone. Okay, that makes sense, slot 1. But if we go to this one, note the location. It's no longer its normal place in slot 6. It's actually in the 3-year vault. 3-year retention, protected data. The point is, it is now out of the system. veeam has no idea where this thing is other than the fact that we created these logical vaults to maintain the location of those tapes. Okay, so now if we go back to the Cloud Lanes interface, what does it do on the other side? Well, take a look. Again, we set it to export the tape automatically upon job completion. You can see here, export in progress, and we will wait for that to complete. We'll see a short spike on egress shortly. May not be very, very large. As I said, this is a very small data set, but it can show you how this process works. The export is now complete, which means that the data from that tape, again, not a lot, a few hundred meg here, was moved up to the cloud. All that's left locally on the landing zone space is metadata pointing to the data in the cloud. So we have effectively now replaced your typical offsite vendors by making it seamless for you to integrate CloudLane's backup accelerator with your backup software to export directly to the cloud. And again, with this job running automatically, there was no human intervention. If we take a look at our cloud repository, we can see here the single storage account that we created, how much of it is being used, how many bytes were uploaded, total capacity available. There is a limit on Azure storage accounts of 500 terabytes. So if you do require more than 500 and are using Azure, you can configure up to 8 storage accounts to attach to the backup accelerator software for a total of 4 petabytes. Back to the dashboard, you can see here the spike on egress as we were sending data out to the cloud. And that is essentially it for backup. So now that we have our backups running, let's take a look at what it takes to restore. If I go down to the Files node, this will include any file type backups or file indexing you did as part of VM backup. There is an option on the D2D VM image backup to provide credentials to crawl the VM to do text searches on it. Those would appear in here, but will also appear in here now is this tape node. And you can see here DC3 share 1. These are the files that we have backed up from that source. And if I want to restore one of those, let's click restore. Yes, that's the object I want. This is the tape that we're going to need for the restore process. So let's start doing that. If this were a very large backup set and you needed more than one, it would list every one that you needed. Okay, so we want 606. Let's go back to the CloudLane's interface, and this is typically one of the very few things you will ever do in this interface once the system is deployed. In order to retrieve a tape that has been exported, in the real world, you'd need to pick up the phone, call your off-site provider, wait for them to pack it up, deliver it, unbox it, and put it in the media access port of the tape library. In our case, we click Import. The import's complete, and what just happened is that we moved that data back from the cloud that we had exported previously, put it back on the local landing zone, and inserted the virtual tape into a virtual media access port that Veeam can see. So let's continue with this job. Send to the original location, overwrite if it's older. And now we're being prompted to insert the tape. Well, we just imported it and it's sitting in the slot, so why doesn't it see it? Well, that's the last piece of manual interaction, is that it's sitting in the port on the library, but we have to tell Veeam to locate it. For that, we will click on the library and import tapes. Now, if you had imported multiple tapes, if this were a backup job needing more than one tape to restore, and you had imported all of those, we provide a large number of media access port slots. You don't need to go through this one by one, import tape, import tape, import tape. You can import in the CloudLane's interface to bring all the tapes down that you need, and then run this tape import inside Veeam once. It will find all the tapes that are in the ports. I've called it a media access port. In this case, Veeam refers to it as an import-export port. The point is that it found the tape, was importing it back to its normal slot, runs a discovery on the library to make sure it still knows where everything is, and what would happen is, note, that job isn't even running anymore. File the tape, restore. Finished. As soon as it saw the tape appear, it completed the restoration. Virtual machine restoration works exactly the same way. It will prompt you for any tapes that you need to restore. So once again, what have we done here? We enabled the tape server role by expanding the tape infrastructure node. There was nothing populated yet. It brought up a little wizard asking us to deploy a tape server. In a simple environment, you can deploy the tape server role to the same server as your veeam backup and replication server, which is what I did here. We then identified the library and the tapes. Remember, it did a scan for the library to see its capabilities, then an inventory to mark all the tapes as free, which it did. We then created separate media pools for our different retention times. And in configuring each of those media pools, we set those retention times inside there. And to match each of these pools on the assumption that when we do a tape backup for archival purposes, we want to offsite it as quickly as possible to the cloud, we created these logical vaults so that veeam can track where these are located. So once we run a backup, we then export the media. The media will automatically, by the Cloud Lane's backup accelerator, be pushed up to the cloud, and veeam will reflect it as being in the proper vault. And again, when you go to restore a backed up item, if it is something that is not held locally in your disk-to-disk incrementals, for example, it will then prompt you for the media that is needed. You would then go to the Cloud Lane's interface, find those barcodes, click import on each, and when they arrive, then you go back into veeam, click on the library, import tapes. It will find all of the tapes that you imported back, bring them into the system, and your job will continue. That's it. That's how we set up the Cloud Lane's backup accelerator with veeam. If you started with this video, you'll want to go back and review the others as well. Refer to the administrator's reference guide as well for more detailed information on the various switches and other configuration parameters that you should keep in mind.